Okay, let's continue with our second learning objective for this lecture. 4.4b, determine and interpret the coefficient of variation. Another simple content that you will learn at this lecture. Okay, our COV is the standard deviation divided by the mean of the same data set and are expressed as a percentage. It is a useful measure for comparing the degree of variation or variability, stability, or consistency from one data set to another. So, COV is equal to standard deviation divided by mean multiply 100%. Okay, for coefficient of variation that has large value or larger value when we are comparing of two data set, alright, if you have your COV larger value, that means your data are more dispersed. When your data are more dispersed, it means that it is less consistent. Meanwhile, if the coefficient of variation, the value is smaller, the data are less dispersed and it is more consistent. Okay, that's how you are going to make comparison of the value coefficient of variation. For example, a larger coefficient of variation means that the data is more dispersed and less consistent. Note that if the expected return in the denominator of the calculation is negative or zero, the ratio will not make sense. Alright, the expected returns that mean excuse me, the mean, right? Alright, so we can take the ratio because it will not make sense. Okay, just remember this formula is just standard deviation divided by mean multiplied with 100%. Okay, which of the data set is more dispersed? Proved by the suitable measurement. So you are given two types of data. Age of the accountant, salary of accountant. So the age, the mean, the average mean for the age are 26 and the salary is 31,000. Meanwhile, its standard deviation given are 6 and 4,000. So let's calculate our value. When we want to see about the data is more dispersed or not, that means you have to find your coefficient of variation, right? So by formula, right, coefficient of variation is equal to standard deviation divided by mean multiplied with 100%. Okay, so let's simplify the COV for each. Is 6 standard deviation, it's 6 divided by 26 multiplied with 100%. So by calculating it, you can get 23.08%. Meanwhile, COV for salary, all right, is 4,000 divided by 31,000 multiplied with 100%. So you will get 12.9%. Okay, so here we can see that the COV of age is greater than COV of salary. So our conclusion will be coefficient of age of the accountant is larger than the coefficient of salary of accountant. Therefore, the data for age of the accountant is more disperse. Alright? So very easy. Okay, let's take a look of our example 4. What do we have? The daily production of two comparable machines was measured over a period of time given the following statistic. So we have machine A and machine B. So let's simplify our writing. So let MA and MB. Okay, given with their mean and standard deviation. Which machine is more consistent in keeping to its mean production level? So we want to know which one is more consistent. So we will need to use our COV. Alright, coefficient of variation is standard deviation divided by mean multiply with 100%. Alright, so I find the COV of MA first. Start with its standard deviation. 41 over 485 multiply with 100. You will get 8.45%. So COV, so I will calculate for COV for MB. Start with its standard deviation, 46,560 multiply with 100%, you will have 8.21%. So as we can see here, COV of MB is less than COV of MA. So to write our conclusion, coefficient of variation of machine B is smaller than the coefficient of variation of machine A. Okay, so by proof of our data. So our conclusion is, therefore, machine B, remember, smaller value, right, mean more consistent. It's more, therefore, machine B is more consistent, excuse me, in keeping to its mean production level. Just take this from the questions, right? So here we are, how we will use our COV. Okay, that's it. Okay, now let's take a look for our final learning objective for this lecture, which is determine and interpret the skewness of data distribution using Pearson coefficient of skewness. Okay, so Pearson coefficient of skewness. The skewness of a data set can be determined by Pearson coefficient of skewness given by. So we have two formula. Alright. How to write it is as sub k. The first formula that we have is 3 multiply with mean minus median over standard deviation. Okay, meanwhile, our second formula is mean minus mode over standard deviation. So as you can see, we have two different formula. So which one are we going to use? It depends on what values that are given or what values are you looking for on before you finding the Pearson coefficients. Okay. Okay, let's continue. Note that when the distribution are skewed, the median generally lies between the mode and median. And the following relationship is satisfied. Alright. So here, how we categorize the value that you are going to get. If your SK, sub k equal to 0, that means the data is symmetrical. If your value is positive, okay, positive value, so it is skewed to the right or positively skewed. But if your value is negative, alright, so it is skewed to the left or negatively skewed. So by using these two formula, you should have the value with the same range, either it is positively skewed or negatively skewed, right? Alright, let's look at next example here. Alright, given that the mean, median, and standard deviation of the following data are 4, 4, and 1.309 respectively, determine the Pearson's coefficient of skewness for the following data. Hence, what can you conclude? Alright, so here are our data. Start with 2, 3, 3, 4, 5, 5, 6. As you already given those three values, so we will use this formula. The Pearson's coefficient equal to 3 multiplied with mean minus median divide with standard deviation. So when we substitute the values, we will get our Pearson's coefficient is equal to 0. Thus, we conclude that the data are symmetrical distribute. Alright, let's look at our last example for lecture 4. We have example 5. Given the following short data, find the Pearson's coefficient of students. So what are these data? These data are raw data. Alright, so now I will just make it short. By using what you already learned before, please find all these values which are mean equal to 2.48, median is equal to 2.45, and I will also find mode equal to 2.4. Besides, I will calculate standard deviation because you will need standard deviation to calculate Pearson's coefficient of skewness is equal to 0.8176. So for this, please use your knowledge before and also use your calculator to find, okay, your knowledge and calculator to find them, right? So let's go to our Pearson's coefficient. Pearson's coefficient of skewness, we know that we have two formula, alright? So you can find the values related to the formula. Usually we will use this formula, okay, the first one. So let's substitute our value first. So equal to 2.48 minus 2.45 divided by standard deviation. So you will get the value 0.1101, or you can also use S sub k equal to mean minus mode over standard deviation. So let's substitute the value. You will have 0.0978. As we can see here, we have the different values for both formula, but the most important is you have the same range, the same, like both of them are positive, so we can tell that it is positively skewed. Right, so that's all for our lecture 4. That's the end for this lecture, and see you later on our lecture 5. Okay, bye.